if you have sums of functions or differences of functions, you can think of doing each function basically on its own and then add or subtract those back together and you get the answer. So an example here, if we have to find the derivative of this long polynomial, it's just the derivative of each individual thing with the sign in between. So it's just using our power rule we talked about previously. Drop down our A tier, new powers one less. The next one, drop down our 5. There is a constant there, so we'll want to multiply those together, which would be 60. Powers 1 less, 4. And we keep going, and we will get our derivative here. When we get to this, these last two, when we're dropped, here the exponent's 1, so when you drop that down, it stays -6. 1 less than our exponent would be 0. You can write x to the 0, but you don't need to because anything to the 0 power is just 1. So that would just turn to -6. And then remember, derivative of our constant there is 0, and so that would be our derivative. If they ask you to find the second derivative of something, this is that same function we just looked at and we found the derivative. Second derivative would be finding derivative of a derivative. So we just go through now and we're looking at this one to get our derivative. So drop down the 7. 7 times 8 would be 56. Powers 1 less again, and you just keep going through and doing a derivative for a second time. So our second derivative would end up being this, because derivative of the last one is a constant again, and that's 0. So when you're doing a second derivative, just find derivative of derivative, rate of change of the derivative.